Given the following table of values, determine an algebraic expression for the inverse. Alright, so first of all what we can do is determine the difference in the y values with the corresponding difference in the x values. So in the x values we can see there is always a difference of positive 1, right? And in the y values, but when like we can see that the difference between 51 and 33 is 18, and the difference between 33 and 19 is 13 minus 9 is 14, and the difference between 19 and 9 is 10, and 9 and 3, this is the difference of 6, right? So we see that there is not a constant difference between the y values, so this means that the function here representing this table is not a linear function. But we can further take the difference and see that this is 4, this is 4, actually negative 4, and this is also negative 4. So now we can see there is a constant difference when we take this like the difference in the second time. So this means that the equation or the function that represents this table is a quadratic function. So let us assume that the quadratic function is of the type y equals ax square plus bx plus c, right? Now we need to determine these three values a, b and c. How we can do that is by using these values. So first of all let's use the value which is x equal to 0 and y equals to 19, that is 0 comma negative 19. So we can substitute the value of y as negative 19 and x as 0, so we'll get a times 0 square plus b times 0 plus c. So this will give us that the value of c is negative 19. Now we know that the value of c is, now we need to determine the value of a and b. So let's use any other 2 points. So let's say that we use the point 1 comma negative 9. So what 1 comma negative 9 will give us is, we'll get negative 9 equals a times 1 square plus b times 1 plus c, right? So this will become and we know the value of c also, so let's substitute the value of c as negative 19. So we'll get that a plus b negative 19 equals negative 9. So this means that a plus b must be equal to what? We can write this as 10, right? Because 10 minus 19 will give us negative 9, right? So we have the first equation over here. Let's write this as equation 1. Now let's see if we can find another equation. So we can use any other point. Let's use this point 2 comma negative 3. So what this tells us is at x equal to 2 the value of y is negative 3. Let's substitute these two values. So we'll get negative 3 as a times 2 square plus b times 2 plus negative 19, right? So we'll get 16 as adding 19 both sides. So this 19 will cancel out and we'll get 16 as 4a plus 2b. We can write this as 2a plus b equals 8. Now we need to solve this equation 1 and 2. So how we can solve equation 1 and 2 is by just subtracting these two equations. So we are subtracting equation 2 and 1. So what we'll get, 2a plus b minus a minus b. So b will cancel out and we'll get 2a minus a. And on the right hand side we'll get 8 minus 10. So this tells us that the value of a is negative 2. Now we know the value of a is. Now we can go ahead and substitute this value of a into any of the equation 1 and 2. So let's use the equation 1. So we get 9 minus 2 plus b as 10. So this tells us that the value of b is 12. Alright. So this is the value of a, b and c here. So now we know what the original function representing the table looks like. Alright, so the original function representing the table must be like minus 2 times x square plus 12 times x minus 19. So this is the function that the table represents. Alright, now we need to determine the inverse of this function, right? So we need to find what is the inverse of this function right here. So this is the quadratic function. We can go ahead and use our method to determine the inverse of any equation given. So this equation is in terms of fx as y equal to something. So we need to determine the equation in terms of x. So what we need to do is we need to solve for x in terms of y. Alright, so this is the quadratic equation and you can easily see that the discriminant here is b square, which is 12 square, negative 4, negative 2, and negative 19. Alright, so this is 144, and this will be 19 times 8, which is like 152, right? 8 9 is 72, 7 8 and 70, right, 15. So this is like negative value, so the discriminant is negative, so that tells us that the root are complex, so we cannot like factor this or anything, so we need to apply the formula, which is like the quadratic formula, which tells us that the value of x from the general equation will be negative b plus minus square root of b square minus 4ac whole divided by 2a, right? So before applying the formula, what we need to do more is we need to change this equation into the quadratic one, which has a 0 on the right hand side. Then only we can apply this formula, because remember, the formula is for the equation of the type, this is for the equation of the type ax square plus bx plus c equal to 0. When you have equal to 0, then you can say that the value of x will be given by this formula. So we can rewrite this equation as negative 2x square plus 12x negative 19 negative y equals 0, because we need to solve x in terms of y. That's why we are taking this y as, so as whole terms of c. So this is all c, so this is c, this is b, and this is the value of a. So now we can go ahead and substitute these values into the formula for quadratic equation, and we'll get the value of x as negative b, which is negative 12, plus minus square root of b square, which is 144, minus 4, a will be negative 2, and c is negative 19 negative y, right, and whole divided by 2 times negative 2. So we can solve this further as x equals negative 12 plus minus 144. So this will be positive 8, and when you multiply positive 8 by negative 19, this is positive 8, and when you do this by negative 19, you will get negative 152, and when you multiply this positive 8 by negative y, you will get negative 8y and whole divided by negative 4, right? So further we can solve this, and we will get x as negative 12 plus minus, this is negative 8, negative 8y whole divided by negative 4. We can take negative 8 as the factor here, and out of the negative 8 the 4 will come out, right? So first of all we can write this as like negative 8 times 1 plus y, right, and negative 4. So negative cannot be bring outside of the square root, we know that, but from 8 we can bring 4, we can like bring 2 outside, because the square root of 8 is like 2 root 2. So from this 8, because this is in now in factored form, we can break this into 4 times 2, this 8 square root. The square root of 8 can be break down into 4 and 2, and then we can write this as a square root 4 times the square root 2 of whatever 1 plus y we have here, negative times, and then this square root 4 will give us 2, and rest will be like the same 1 plus y. So from here we can get negative 12 plus minus 4, like we'll get 2, then negative 2 1 plus y, alright, and whole divided by negative 4. Now we can take 2 common from this 12 and 2, and this 2 that we took common, we can cancel it from the denominator 4. So there is a further step we can do. This will come out to be negative 6, or we can break this negative 4 into both of the fractions also. So we can get negative 12 over negative 4, and we can get plus minus 2 square root negative 2 1 plus y over negative 4, right? So this will become 3 plus minus negative 2 1 plus y over like negative 2. Alright, so we have two functions here, so the inverse is equal to, So this is the value of x that we are getting, right? This is the equation for x. So we know that we can interchange the variables x and y here and write this in terms of y equal to something also. So the inverse of the function is, so this will be 3 plus, when you take plus you will get minus, when you take negative you will get plus because of this negative also. So we can write 3 plus square root negative 2 1 plus y over 2, and when you take the positive sign this will become negative because of this negative, so we'll get 3 minus square root of negative 2 1 plus y over 2, right? So these are the two functions that represent the inverse of our given function. Alright, so one more thing that we can do is go ahead and check which of the function satisfies our given coordinates. So from the table we can see that the coordinates for the function, let's take this 0 1 was 0 comma negative 19. So for the inverse function the coordinates will like interchange and will become negative 19 comma 0. So this point should satisfy the inverse function. Let's see. So we have to substitute x as negative 19 and we should get 0. So let's do this in both of these functions that we get. So f inverse of negative 19, we are going to calculate this. So first of all let's substitute, this will be negative 2 1 negative 19 over 2, right? So this will be 1 minus 19 is negative 18. Negative 18 times negative 2 is 36, which will be positive. So we will get 3 plus positive 36 over 2. So this will give us 3 plus 6. The 2 is not on. Okay, so the 2 is not on like 3 here. Alright, so we'll get 6 over 2. So we'll get 3 plus 3, which is like 9. Let's try to substitute here also. So in this function we'll get 3 negative, and this is like the same thing. So here also we'll get square root of 36 over 2. So this time we'll get 3 negative 6 over 2, and this is 3. So we'll get 3 minus 3, which is 0, right? So in this case we are getting 0. So we can say that the inverse of the function is represented by this expression over here.